All right, so what you guys will be doing today is momentum practice problems worksheet. Let's go ahead and get into it here. So number one says two objects A and B have identical velocity. So moving at the same velocity. Object A has 3 times the mass of object B. Compare the momentum of each object and justify your answer. So momentum, the equation for momentum is this. Alright, so if they have the same velocity, we'll call this object 1, object 2, momentum equals mv. They have the same velocity, but one has 3 times the mass as that one. They're going to have 3 times the momentum. Alright, so mass and velocity directly proportional. It's 3 times the mass, so it's going to be 3 times the momentum. Two other objects, C and D, have identical masses. Object C has twice the velocity. So basically it's the same thing, except now their masses are the same. Masses are the same, and one has 2 times the velocity. Alright, so it's going to increase by a factor of 2. So this momentum will be 2 times the momentum of that one. Alright, so while being thrown, a net force of 132 newtons acts on a baseball, mass of 140 grams, for a period of 4.5 times 10 to the second, or 10 to the second seconds. What is the magnitude of the change in momentum of the ball? Alright, so as you guys saw, you're going to have this equation here, this impulse momentum equation. 3. F delta t equals m delta v. Alright? So this side is equal to change in momentum. This side is equal to impulse. Alright? So anytime they give you a force, you're probably going to be working with the impulse momentum theorem equation. So go ahead and let's list what we know here. I know that it gives a force of 132 newtons. It gives me a mass of 140 grams. I need to convert that to kilograms, so I put there are 1,000 grams in 1 kilogram. So I get 0.14 kilograms. And a time of 4.5 times 10 to the second seconds. Alright, so it asks for what is the magnitude of the change in momentum of the ball. Well, change in momentum is this side. They don't give me any velocities, but what you should know from this equation is this. If you can find one side, right, we're given a force and a time. I could find the total of that side. Well, if I know that what that side equals, I know that that side has to equal the same thing. There's an equal sign there. So the impulse is equal to the change in momentum. So even though it asks us to solve for change of momentum, I'm going to solve for the impulse because I know that's the same as that. So I can just quite simply do change in momentum is equal to force times delta t. Delta rho is equal to force is 132, time is 4.5 times 10 to the negative second. Plug in. Alright, so in your calculator again, you do 4.5 second EE negative 2 times 132. You get 5.94 kilogram per meter per second. Alright. Now, look here. There's no 4, so we go to 5. It says the batter hits a ball, net force 132 newtons, opposite the direction of the ball's initial motion. Opposite to the ball's initial motion. Acts on the ball for 9.0 times 10 to the third seconds during the hit. What is the change in momentum of the ball? Alright, so again, we're given a force. So again, I'll probably be using this one. So this is number 5. Number 5. Alright. So let's see what it gives us here. It gives us force 132 320 newtons. Time is equal to 9.0 times 10 to the negative third. It says, what is the change in momentum of the ball? So again, the same thing. We want to know change in momentum, but we're not given a velocity there. We can find impulse. So I can set change in momentum is equal to F delta T. F is 1320. Time is 9.0 times 10 to the negative third. I can go ahead and do that in my calculator. I get 9.0 second EE negative 3 times 1320. I get 11.9 kilogram meters per second. All right. Pretty easy stuff so far, just working with that impulse momentum theorem. Okay? All right. So the next question talks about the same question, just asks a different question. It says, what force does the ball exert on the bat? Well, it says the bat puts a force of 1,320 newtons onto the ball. Okay, so from Newton's third law of motion, so for number 6, from Newton's third law of motion, for every action there's an equal and opposite reaction. So the answer to this is just the same. The force that the ball exerts on the bat is the same as the problem above. It's 1,320 newtons because every action has an equal and opposite reaction. All right, pretty easy so far. 7. A golf ball that weighs 0.45 newtons is dropped from a height 1 meter. Assume that the golf ball has a perfectly elastic collision with the floor. Okay, determine the time required for the ball to reach the floor. So that's going to be one-dimensional motion stuff. Let me go ahead and draw this. So number 7, you have a ball falling to the floor. It means initial velocity is 0, gravity is there, negative 9.8 meters per second squared. What else does it give us? It gives us the height is 1 meter, so I know delta y here, delta y, it goes down 1 meter. I want to know velocity final. With what velocity does it hit the ground with, right? Determine the time the time required. I want to know time. How long does it take to hit the ground? Look at your equations here. You could use this one. So for A, you use delta y equals VIT plus 1/2 GT squared. VI is 0, it goes away. Negative 1 equals 1/2 negative 9.8 T squared. Solve. Negative 1 is negative 4.9 T squared. I divide by negative 4.9. I get T squared is equal to 1 divided by 4.9. I get 0.20. Square root both sides. Time is equal to 0.45 seconds. So no impulse momentum yet. That's just asking some one-dimensional motion problem. All right. It says, what will the instantaneous momentum of the golf ball be immediately before it strikes the ground? So we want to figure out right before it hits the ground, right here, what its momentum is. We want to know momentum. Well, momentum is equal to mass times velocity. Well, they give us the mass of the golf ball. Well, it gives us its weight. Weight is equal to 0.45 newtons. So we can find mass. Weight is equal to mg. 0.45 is the weight. Mass is what I'm looking for. G is 9.8, so I divide by 9.8. The mass of the golf ball is 0.45 divided by 9.8. I get 0.04 kilograms. All right. So if I can figure out the velocity right before it hits the ground, I'll be able to find that. So what I want to do is, using the same variables, I want to find VF. So I could quite simply do this. I could use VF equals VI plus GT. All right, VF is what I'm looking for. VI0 goes away, negative 9.8. T is 0.45 seconds. VF equals 9.8 times 0.45. Yeah, and I get negative 4.4 meters per second. So that's how fast it's going there. So what I can do now to find the instantaneous, I just use my basic impulse, or my basic momentum equation here. Because I know it's traveling at this point at 4.4 meters per second, and it asks me what's the momentum at that point. So I plug in. Momentum equals, mass is 0.04 times 9.8. Momentum equals. So I do 0.04 times 9.8, I get 0.4 kilogram meter per second. All right. Now it says, what will the change in momentum be from the instant the ball collides with the floor to the instant after it rebounds the floor? Okay, so what we want to do here, actually, I did that wrong. Hopefully you saw that. Let me rewind a little bit. I use gravity. It's momentum is equal to mass, which is 0.04 times the velocity, which is negative 0.44. Sorry, messed up numbers here. So I got to do 0.04 times negative 4.4. I get negative 0.17 kilogram meter per second. All right. So yes, it should have a negative because it's going down here. So C asks, what's the change in momentum? Well, change in momentum is equal to momentum final minus momentum initial. Well, if it's elastic, it means it's going to remain the same. So it's not going to lose any energy. So initially, before it hits the ground, it has that momentum. So initial momentum before it hits the ground is equal to negative 0.17. Negative 0.17. After it hits the ground and rebounds with the same velocity, it's going to have a positive 0.17. So change in momentum is equal to 0.17 positive minus the negative 0.17. So change in momentum is equal to 0.17 minus a negative 0.17, which gives me 0.34. All right. D. Suppose golf ball is contact with the floor for 0.04 seconds. What was the average force in contact? Okay, so now it's saying we're looking for force. What force did the floor put onto the ball to make it change its direction? Well, again, if you're looking for force, you can use F delta T equals M delta V. We're looking for force. It gives us the time. The time is equal to 4.0 times 10 to the 4th. So it's 4.0 times 10 to the negative 4th seconds. Well, I found, remember, this is equal to change in momentum. That's my change in momentum right there. So I can go, force is what I'm looking for, times time, which is 0.0 times 10 to the negative 4th, equals mass, change in momentum I found to be 0.34. So all I have to do is divide by 4.0 times 10 to the negative 4th, 4.0 times 10 to the negative 4th. I get force is equal to 0.34 divided by 4.0 second EE negative 4. And I get 850 newtons. All right? Good. Number 8 says Kim holds a 2 kilogram air rifle loosely and fires a bullet mass 10 grams. The muzzle velocity of the bullet is 150 meters per second. What is the recoil speed of the rifle? Okay, so this is a before and after problem. So you're going to be using the law of conservation of momentum. All right, so let me draw the pictures first. Okay, so you have before she fires a gun, so 8. Here's Kim with a gun. All right, before she fires a gun. All right, after she fires the gun, because she's holding it loosely, the gun is going to recoil that way, and the bullet is going to travel that way. So one way is positive, negative, positive, negative. So you start by doing this. Momentum before is equal to momentum after. Okay? So before, if the bullet is just sitting in the gun and the gun is just being pointed there, are they moving? No. So if nothing is moving, my total initial momentum is going to be equal to 0. Then they fire the gun. So now I have to account for this. Ask yourself, how many objects are moving? Well, 2 objects are moving. So you have to account for that. You go mass of the bullet, velocity of the bullet, plus mass of the gun, velocity of the gun. Okay, you've accounted for both things there. Now you can kind of plug in. 0 equals, mass of the bullet is 1 gram, so that's 0.001 kilogram. Velocity of the bullet is 150 meters per second. Plus, mass of the gun is 2, and you're looking for this recoil velocity, which will be the velocity that the gun moves with. So quite simply, you can solve, so I'll simplify here. I get 0 equals 0.001 times 150, gives me 0.15 plus 2 VG, velocity of the gun. Subtract 0.15 minus 0.15 equals 2, velocity of the gun, divide by 2. Velocity that the gun has when it recoils is negative 0.15 divided by 2, which gives me negative 0.075 meters per second. Okay, so that's how fast it's going to recoil. All right. Number 9. If the girl in the previous problem holds the previous question holds the rifle tightly against her body, the recoil speed is less. Explain. Okay. So when you hold the gun out, right? Anybody that knows hunting, you don't hold a shotgun out and fire it, right? Because there's so much momentum, it's going to kick back and hit you in the face or whatever. You hold it tightly against your shoulder and rest the butt of the gun up against your shoulder. Hold it tightly. So in fact, you're basically adding the mass of your body to the gun. So it holds it tightly and lessens the recoil speed. So let's draw that now. So this is number 9 because it says calculate the new recoil speed if she holds it tightly. So, number 9. Now the girl is holding the gun tightly. It's against her body. Alright? Then when she fires, okay, it's still going to have a little bit of recoil, so I'm still going to draw it, and the bullet's still going to go out. So positive, negative, positive, negative. So I start with momentum before is equal to momentum after. Alright? So again, before she fires the gun, nothing's moving. So I can set initial momentum equal to 0. Now, here's what's changed. The bullet's still moving, so I'll do that. Mass of the bullet, velocity of the bullet. Now, we have to think that the gun and the girl are basically locked together as one. So how do I mathematically represent two things combining? Well, I add their masses together. So now I'm going to have mass of the woman plus mass of the gun times their both combined velocities. All right, and that's the velocity we want to find. So again, I plug in 0.001, 150 plus mass of the woman is 48. Mass of the gun is 2. Velocity. So again, I simplify. 0 equals 0.15 plus 50 velocity. Subtract 0.15. I get negative 0.15 equals 50V. Divide by 50. Divide by 50. I get velocity. The new velocity when she holds the gun is equal to 0.15, negative 0.15 divided by 50. I get 0.003. Negative 0.003 meters per second. So as you can see, it's a lot less than before. It's a lot less than before. Okay? All right, good. Number 10, it says, in a freight yard, a train is being put together from freight cars. An empty freight car coasting at 10 meters per second strikes a loaded car that is stationary. The cars couple together. Each car has a mass of 300 kilograms when empty, and the loaded car contains 12,000 kilograms of canned soda, a year's supply for the physics class. All right, with that speed, with what speed does a combination of the two cars start together? So again, this is going to be a before and after. So let's go ahead and look at what we got here. So you're going to draw a picture here because you're going to make your equation off of that. So 10. All right, before, you have a car. Let me see. Okay, the empty one's coasting this way. All right, then you have one that has a soda on it. That's the soda. It's stationary. Called this way positive, this way negative. They collide together and then go down the road. So I'm going to draw them together. And they're going to go down the road with some velocity. That's a velocity we want to figure out. So again, I start with momentum before is equal to momentum after. Well, how many objects are moving here? I'll call this cart 1, I'll call this cart 2. You only have one moving, so you only have to represent one here. So I do mass of 1, velocity 1, equals. Again, we combine their masses. So I do, because they're moving together. They have the same velocity. They're basically moving as 1. So I do mass of 1 plus mass of 2 times their final velocity, mass after. So that's the velocity that I want to figure out. So let me go ahead and plug numbers in here. The mass of an empty cart is 3,000. So I do 3,000, and it's moving at 10 meters per second before, equals. Mass of cart 1 is 3,000 plus. Well, a cart is 3,000, and the cans are 12,000. So that second cart is actually 15,000, and velocity after. All right, so let's go ahead and solve for this. This is 30,000. I solve that, I get 18,000. Velocity after. I divide by 18,000. Velocity after equals 30,000 divided by 18,000. 1.7 meters per second. So those carts will be traveling at 1.7 meters per second after they collide. Okay? All right. An astronaut whose mass is 80 kilograms carries an empty oxygen tank with a mass of 10 kilograms. He throws the tank away from himself with a speed of 2 meters per second. With what velocity does he start to move off in space with? Okay? So let's go ahead and draw this. So you have an astronaut holding a tank. He throws the tank. He was actually going to move that way while the tank moves that way. Positive, negative, positive, negative. All right, everybody agree that scenario should make sense here. So I got momentum before is equal to momentum after. I look here. How many things are moving? None. So initial momentum is equal to 0. How many things are moving? I have 2, so I have to represent that. Mass of the astronaut, velocity of the astronaut, plus mass of the container, velocity of the container. I go ahead and plug in. 0 equals. The astronaut is 80. We want to know how fast he moves. Yes, so I'm going to leave that. Velocity of the astronaut plus mass of the can is 10. And he moves off and he throws the can at 2 meters per second. So I go ahead and simplify. I get 0 equals 80 VA, velocity of the astronaut, plus 20. Subtract 20. We get negative 20 equals 80 VA. Divide by 80. Divide by 80. I get velocity of the astronaut is equal to negative 20 divided by 80. I get negative 0.25 meters per second. All right, negative 0.25 meters per second. Should make sense. Like we said, his velocity is drawn in the negative direction. Pretty easy problem here, before and after. Number 12 says, a tennis player returns a 30 meters per second serve straight back at 25 meters per second after making contact with the ball for 0.5 seconds. If the ball is a mass of 0.2 kilograms, what is the force exerted on the ball? So again, we're looking for force. What is this, 12? Yeah. Again, we're looking for force, so we'll probably be using F delta T equals M delta V. So what's important here is you need to draw a picture, okay? Because it's a simple picture. You have a ball going in, and then a ball that gets hit back out in the same direction. Well, one way has to be positive, and one way has to be negative. That's important. If you don't keep your positive and negatives here correct, you're going to get this problem incorrect, even though it's really, really basic. So the serve that comes in, velocity initial, is 30. The serve that comes out, velocity final, since it's going the opposite direction, is negative 25. This is where kids will mess up. They won't put the negative here because it doesn't say negative in the problem. That's why it's important to draw that little photo. It has a mass. It says 0.2 kilograms. And in contact for half a second. I want to know the force, right? So remember, you can expand this. F delta T equals M VF minus VI, which is just delta V. Delta V is equal to that. So I'm looking for F. I know this is 0.5. Mass is 0.2 times velocity final, negative 25 minus 30. I'm going to go ahead and simplify here. I get F 0.5 equals 0.2 times, what was that, negative 55. Simplify. F 0.5 equals 2 times, or 0.2 times negative 55 gives me negative 11. I divide by 0.5, divide by 0.5. Force is equal to negative 11 divided by 0.5. I get negative 22 newtons. And think about it. Why is it negative? Well, the racket is being swung that way, right? So the force that the racket applies onto the ball is in the negative direction. All right? Okay, good. I hope that was a good introduction to momentum.